In this section of the lecture, I'm going to be talking about the Malthusian era. This is a period that I've mentioned a couple of times previously, a period that we usually associate with relatively slow or little increase in living standards over time. In this graph, I've shown some data that we've seen before, which shows material well-being in Europe from 1500 to 1850. The main point with regard to the Malthusian era is the absence of increase in living standards in the period up to about the middle of the 17th century. Another point I want to make is that at the same time there was also relatively little or only slow growth in population in Europe, again by the standards of what came after. So again, for all these countries in Europe, we've got population in the thousands on the vertical axis, and you can see that while there was some increase in population, the population before about 1700 increase in population was quite slow with what happened after. In this graph, what I've done is put these two variables, real wages and population, or think of real wages as a measure of income, and population for England together for the period from 1260 to 1860, using Greg Clark's series on real wages of craftsmen. Each point on the graph represents a different point in time. On the horizontal axis is population in millions, on the vertical axis is an index of the real wage. What you notice is that from the period from the start of the data in 1260 through to about the middle of the 17th century or early 18th century is that all of the observations fall close to a downward sloping line that characterises a relationship between real wage and population. In other words, an inverse or negative relationship between the real wage or population, or what I'll refer to as a trade-off between them. Then, from the mid-17th, 18th century onwards, we see that that kind of inverse relationship breaks down and we start to get increases in both the real wages and population, with an increasing distance between the dots showing that that rate of increase in real wages and population was accelerating over time. So what this graph is telling us is that for quite a period in England, from 1260 through to the 17th century, 18th century, there was a relationship between income and real wages and population where there was a trade-off between those two variables. After that, that trade-off is broken and we get increases in both the real wage and population. How can we think about the first period, the period before the end of the 17th century, where we have this trade-off between real wages and population? Well, one person who thought he knew the answer was Reverend Thomas Malthus, who was an English clergyman. In 1798, he published a book, an essay on the principle of population, where he gave his theory for why this trade-off existed. Malthus believed the trade-off existed because of a country's capacity to produce food, that what established a link between income and population was a country's capacity to produce food. He thought that that was governed by a law called the law of diminishing returns. The law of diminishing returns tells us about what happens to output. In this case, we're interested in the output of food when we add extra workers to production. Malthus understood that if you had more population and hence more workers, it's likely that you'd be able to produce more food. But what he was interested in was the extra amount of food that would be produced when you added an extra worker. And he thought with a fixed amount of land in England, that would be governed by the law of diminishing returns. The law of diminishing returns says that each extra worker you add adds a diminishing or a smaller amount to total output. If that happens, then it implies that the average amount of output produced by each worker is going to be falling. So in other words, as population increases, as the number of workers increase, the average amount of food available to each of them is going to decrease. In this table, I've given you a numerical example of how the diminishing returns idea works. So in the left-hand column, I've thought of there being different possible number of workers, 1, 2, 3, 4, 5, and I've made up some numbers for the total output of corn that they might have produced. So if there's 1 worker, that means the total output of corn is 10. If there's 2 workers, 18, 3 workers, 24, 4 workers, 28, 5 workers, 30. That means the first worker adds 10 compared to having no workers at all. The second worker adds 8, 18 minus 10. The third worker adds 6, 24 minus 18. And the fourth and fifth workers add 4 and 2. So this is the idea of diminishing returns, that each extra worker adds less to total output than the previous worker. Now, if you have diminishing returns, then what that means is that average output is also going to be falling. So average output is just the total amount of output of corn divided by the number of workers. So if there's 1 worker, it's 10. If there's 2 workers, it's 18 divided by 2, which is 9. If there's 3 workers, it's 24 divided by 3, which is 8. So you can see that with diminishing returns, the average output of corn per worker falls as we add more workers. That's something that I've summarised in this graph, which I'm calling the diabolical trade-off. On the horizontal axis, I've got food per person in the population, and on the vertical axis, population or number of workers. And essentially, the numerical example on the last slide was showing this type of inverse relationship, that the more population and workers we got, the lower the amount of food per person that we would have. Malthus went further than saying that there was this diabolical trade-off. Malthus also thought that there was a particular path along this trade-off line that society was likely to follow. Malthus thought that there were forces that would tend to cause population to increase over time. On the line showing the trade-off between food per person and population, that, for example, would be a shift from point A to point B. So we're moving from a point with a lower population, more food per person, to a point with higher population and less food per person. The problem with that is that as population keeps growing and as the average amount of food per person keeps declining, you get to a point where the amount of food available per person would hardly be sufficient to sustain life. And that's where Malthus thought an adjustment would come in. There would be an event like a famine because of the shortage of food, or there might be a war as countries fought with each other to try and get extra land, agricultural land, to feed their populations. If that happens, then we move back down the line from point B back to point A. And so Malthus thought that through famine or through war or other similar forces, that equilibrium would be restored for a time, and then population would begin to increase again and the cycle would start again. Now, like many great economists, Malthus was a wonderful writer, and so it's worthwhile quoting him on what he thought this adjustment mechanism was. Malthus said, "The power of population is so superior to the power of the earth to produce subsistence for man that premature death must in some shape or other visit the human race. The vices of mankind are active and able ministers of depopulation. They are the precursors in the great army of destruction and often finish the dreadful work themselves. But should they fail in this war of extermination, sickly seasons, epidemics, pestilence and plague advance in terrific array and sweep off their thousands and tens of thousands. Should success be still incomplete, gigantic inevitable famine stalks in the rear and with one mighty blow levels the population with the food of the world." Probably the biggest example during this period of this type of adjustment between income or food per person and population was during the Black Death. In the Black Death, there was a large decrease in the population in England. So on this graph, I've got sort of period from 1260 through to around about 1600, and I've got population measured in hundreds of thousands, and the real wage, an index for the real wage measured here as well. And you can see that sort of from around the time of the Black Death in the late 1340s, the English population begins to fall. At the same time, you see real wages increase substantially in England. So this is this idea of an inverse relationship between population and real wages, or the amount of food that you could afford. That as population decreases, living standards increase. But then living standards having increased is going to promote population growing again, and so we see that eventually population starts to increase again. And once population starts to increase, then that brings down the real wage or living standards. So the Black Death is an example of this diabolical trade-off in history. Now, Malthus's stories about famine and pestilence are dramatic. There's also another possible adjustment mechanism that you can think of for bringing population into equilibrium with food producing capacity of a nation. And that's through adjustment to the birth rate, what's often called a positive check on population. So the idea is that as living standards decrease, as the amount of food available per person decreases, that would cause a decrease in the birth rate, which would cause a downward adjustment in the population. And evidence from parish records in England suggests that in fact this type of relationship did exist. When incomes were lower in England, it seems that people married later and put greater spaces between their children. Now, in describing Malthus's theory, I've been making a couple of implicit assumptions. That the level of technology that we use to produce food is unchanged, and that the amount of land is unchanged. What would happen if we were to relax one or both of those assumptions? Well, suppose we think of there being technological change. The way we'd want to represent that in terms of the diabolical trade-off is we'd want to show a new trade-off that's an outward shift of the old trade-off curve. This is basically showing that for any level of population, we can get a bigger amount of food than we did before. So there's been some change in technology, which means that at any given level of population, the country or society is able to produce more food than it did before. How would that play out in terms of changes to population and living standards? Well, I've described that on the next slide. In the short run, what we'd expect is that if there's a technological change that makes an economy able to produce more food, to be more productive, population is just going to stay the same, and so we're going to move from point A to point B. So there's going to be an increase in the food per person and population stays the same. But once living standards have increased in that way, then that's going to promote the birth rate, because there's a higher amount of food per person, and it's also going to lead to a decrease in the death rate because people are healthier. And so population will start to increase, and so again we start to move up our new trade-off curve. And we'd expect that that will only finish this adjustment of population once we get back to an equilibrium between the birth and death rate, which is going to happen at the old level of food per person. So the prediction is that in the Malthusian model that if you have technological change, that in the short run increases the amount of food per person, but in the long run is only going to cause an increase in population, and you'll return to the old amount of food per person or living standards. What evidence do we have about the Malthusian model as an explanation for what was happening during this period of time? Well, in recent research by Kamral Ashraf and Ided Galor, they looked at 147 countries in the years AD 1, 1000 and 1500. And they tested the idea that population could be related to technology or land availability or land quality, but that income per capita, food per person, shouldn't be related to that. And they found that for those 147 countries, that hypothesis was borne out. They found that differences in population densities between the 147 countries in those years were related to a proxy for technological sophistication and land productivity, but income per capita at that time was unrelated to those variables. So over a long period of time, it does seem there's some evidence for the Malthusian model. Of course, we shouldn't think that the Malthusian model is a perfect fit or explains everything that was happening to income and population during this period. For example, we've seen that the Netherlands, during the period that we count as the Malthusian era, was able to have large, by the standards of the time, increases in living standards. We also know that there were other factors apart from the Malthusian dynamic which had a strong influence on population. For example, the effects of climate. It does seem generally accepted, though, that Malthus's story about the capacity to produce food through the law of diminishing returns constraining the rate at which population and income could increase provides a large part of the story about what was happening in Europe and England before 1650. And so Joel Mackier and Hans Joachim Voth, who've reviewed the evidence on what was happening in this period, conclude that there's strong evidence that Malthusian restrictions bound in England before 1650. Malthus wasn't just interested in understanding what was happening to population and income, he was also interested in the policy implications. In fact, that was what first attracted him to write his essay, an essay on the principle of population. The full title to the book includes the name of Condorcet, Owen and Godwin, three writers of the time who were arguing that the English government should be doing more to support the English working class and poor. Malthus believed that to provide support to the working class and poor was actually self-defeating. He believed that if you gave that support, all it would do would be to promote reproduction, increase the rate of reproduction, increasing population, and thereby hastening an inevitable adjustment backwards in the population. Malthus's views were influential with English government and were embodied in the Poor Laws of 1834, which restricted assistance in a variety of ways compared to what had been the case before. Now, not everyone in society agreed with Malthus's views at the time, and one person who didn't was Charles Dickens. Sylvia Nasser, in her History of Economic Thought, Grand Pursuit, talks about how you can interpret his novel, A Christmas Carol, published in 1843, as an allegory against the views of Malthus. So, Ebenezer Scrooge in A Christmas Carol says of the poor in the workhouse, they cost enough and those who are badly off must go there. The Ghost of Christmas Past objects that many can't go there and would rather die. To which Scrooge responds, if they would rather die, they had better do it and decrease the surplus population. So Dickens is really almost quoting from Malthus there with these words about decreasing the surplus population. Of course, as you probably know, the novel has a happy ending. To save the life of Tiny Tim Cratchit, Scrooge repents and thereby, as Sylvia Nasser puts it, refutes the grim Malthusian premise that the blind and brutal past is destined to keep repeating itself. Of course, as we've seen, once we get close to the Industrial Revolution, then the type of Malthusian relationship, the diabolical trade-off between income and living standards, income and population, disappears. So does that mean that Malthus is of no relevance to us today? Well, perhaps not. Two economists, Daron Acemoglu and Simon Johnson, looked at the effects of the public health revolution in the 1940s. So that was developments like penicillin and streptomycin, for example, new drug therapies which have a significant effect on capacity of medicine to treat different diseases. And what they looked at was the effect of that public health revolution on the rate of growth subsequent to the revolution in a whole lot of countries around the world and changes in life expectancy. In this graph, what I've shown is on the horizontal axis percentage growth in population from 1940 to 1980, and on the vertical axis percentage growth in GDP per capita from 1940 to 1980. And so you can see that if we take the average relationship of all these points, that in fact there's an inverse relationship between population growth and change in GDP per capita. So countries where the population growth was highest saw the smallest growth in GDP per capita. countries on average that had the smallest growth in population, they saw the largest growth in GDP per capita. Now this is not exactly the same as the Malthusian trade-off, in that all of the countries here have had positive growth in their living standards, whereas in Malthus's time we were talking about living standards decreasing and increasing depending on what was happening to population. Here it's rather the idea that the rate of growth, the rate to which you've had a positive increase in living standards, is traded off against the extent to which population size increases. The underlying mechanism is the same. As The Economist magazine wrote about this research, increased life expectancy led to higher population using a limited stock of things like land and capital, thus depressing income per person and wealth. So in this section of the lecture we've seen a theory through which it's possible to explain why living standards and population were relatively static in the period leading up to the Industrial Revolution, and the possibility that Malthus still has something to tell us today about the relationship between population and living standards. In the next section of the lecture, I'll move on and talk about the rise of the Atlantic traders.